Describe how current in loop B changes when the voltage source is turned on. So this is just a very, very simple transformer. We have here a DC power supply, which will make things a little bit interesting, and just two simple circuits. Now normally when we think about transformers, we think about AC current. So what will happen when the voltage source is turned on here? Well, obviously we know that once there's a constant current flowing through loop A, there'll be no changing flux and no effect on loop B. But what happens just as it is turned on? First of all, we have zero current, and then suddenly we have lots of current. So that means that we go from no magnetic field to an existing magnetic field, and that's a change in flux. So let's write that down. When a current starts flowing clockwise through loop A, it creates a magnetic field. So what will this magnetic field do? The magnetic field will be, the current will be going around in the clockwise direction. We can see that from the power source. And so it'll create a magnetic field pointing in a particular direction into the page. And that means that loop B will oppose this change, and it will create a magnetic field coming out of the page. And to do that, it'll need to have a current flowing in the opposite direction. So, when the magnetic field increases, which is almost instantly, from 0 to a constant value, it's changing because it's increasing from 0 to something, and it induces an anticlockwise current through loop B, according to Lenz's law. Of course, we need to say what happens after that as well. When the magnetic field reaches its constant value, there is no change in flux, so current stops flowing in loop B. Fairly straightforward.